Hello everyone. In this video, I will show you how to analyze tokens in an expression of a language. We know that a compiler consists of four phases to translate a program from high-level language to machine object code. The first phase is called lexical analysis. Lexical analysis is analysis of the individual characters in a computer program to help assemble them into parsable units called tokens. That means lexical analysis is to figure out tokens in expressions of the program code. So how to identify the tokens from a given expression of a language? For example, in our exercise, suppose the given language has a syntax defined here. An expression can be defined as an expression add another expression. So this is one definition. An expression can be defined as one expression add another expression. Or this is not a part of the definition. It's just a mark to divide an expression with from another expression, from another definition of the expression. Or an expression can be defined as an expression subtract another expression, or an expression multiply another expression, or an expression equal to another expression, or an expression smaller than another expression, or an expression enclosed in a pair of parentheses, or a term. So we can see an expression can be defined two expressions to add up together, or an expression subtract another one, or an expression multiply another one, or an expression equal to another expression, an expression smaller than another expression, and an expression enclosed in parentheses, or a term. So all the others have expression and need to be further defined until the expression is defined as a term. Now we need to define the term. A term can be defined as A, B, C, D, E, F, G, or H. Okay. So for example, here A plus B plus minus C, this should be a legal expression created from this language, generated from this language. Because why? A is an expression, or A is a term, so it is an expression. B is a term. Okay, a term is an expression. So an expression add another expression, that is this definition. And this definition, this become an expression. And this expression subtract C is a term, and the term is an expression. So A plus B is an expression. Subtract C is another expression. That is this second definition of the expression here. So that means this expression A plus A add B subtract C is a legal expression, can be induced from this language definition. Okay. So how about, let me say, is A multiply B, B's exponentiation 2, is this an expression, a legal expression in this language? No, right? Because the exponent is not defined in the language. This operator is not defined in the language. How about x plus y multiply z? No, because x, y, z are not defined in the language. They are not legal terms in the language. Okay, so both of these two expressions are not legal expression in this language. But these three are legal because we can induce them from the definition of expression. All right. Now, we will have a question. In this language, depicted above, that is in the definition here, expression and term. How many different lexical tokens are there? So that means how many lexical tokens. What are the lexical tokens? The lexical tokens contains the operators in the definition and the terms. Okay, the terms. So from the definition of expression and term, we know that like add is the operator, right? Subtract, multiply, equal, less than or smaller than, the parentheses. These are operators, or like parentheses is punctuation. These are legal or legal lexical tokens in this language. And also the terms A, B, C, D, E, F, G, H, they are terms. So they are all the lexical tokens. How about the XP in the angle parentheses? This is just a concept. This needs to be defined. Okay, so you cannot count this to be a token because they need further defined. And also term is a concept, need to be further defined. All right. So here the expression and terms are just the concepts to be defined. They are not lexical tokens. Okay. So once you count the operators and the terms, you know how many different lexical tokens are there, right? So what are the lexical tokens I have mentioned? The operators and the terms and the punctuations, like the left and right parentheses. So give these expressions, what are the lexical tokens? Okay. For example, the first one, we know that there are many add. Everyone is a token, right? Even though they are the same token, the same operation, but each of them is a token, so that you need to count them the times, how many times they are used in the expression. Okay. So this is about how to identify the lexical tokens from a given expressions. You need to compare against the definition, all right, to identify the operators, the terms, punctuations. Otherwise, if a given expression that have some symbol not defined in the definition, then it's not a legal lexical token of the language. Like this one is not, because the carry operator is not defined in the language. And the other one is like this one, X, Y, Z are not the terms that can be not the defined terms. Okay, the terms only include A, B, C, D, E, F, G, H, no others. All right, so that is also not a legal expression in the language. Okay, so I hope this helps you.